Imagine an NFL stadium packing in, 80,000 screaming fans. The referee clicks his microphone to make a game-deciding penalty call, and nothing happens, just dead silence. Today, we are diving into a product breakdown from HDTVSupply for the QSC QIO-L24o Q-SYS network expander.
Quite the mouthful.
It really is. But our mission today is to uncover the invisible technology that keeps massive audio systems running flawlessly. You are basically looking at a $2,850 universal translator and safety net for giant sound setups.
Yeah, I mean, it really is the unsung hero of live audio. When you are dealing with massive event productions or, say, high-stakes judicial spaces, the sheer volume of data moving around is just staggering.
Right.
And the margin for error in those environments is exactly zero.
Okay, let's unpack this. To understand why an expensive piece of gear like this even matters, we first have to explore the major problem it solves, which is getting old-school analog gear to talk to modern digital networks.
Exactly. Because historically, getting sound from a microphone on the field all the way up to the speakers in the rafters meant running literal miles of heavy, fragile analog cables.
Just a total logistical mess.
Oh, an absolute nightmare.
Like that.
What's fascinating here is how this device bridges that gap. The QIO-L24o integrates non-networked mic-inline audio directly into the cloud-first QSYS AV platform.
So you just drop it where the actual microphones are.
Right, you plug them in, and it translates that analog audio into digital data, sending it all over a single standard network cable back to the main system.
And doing all that in this form factor is wild. It is a 1RU device, meaning one rack unit, so only 1.75 inches tall.
Barely any space at all.
Right. But it boasts 24 line-level outputs, plus 48-volt phantom power for those professional condenser mics, and an 8x8 GPIO for third-party control. Cramming this much input-output connectivity into a 1RU box is, well, it is like stuffing a symphony conductor into a shoebox.
That is a brilliant way to put it. By separating those physical inputs and outputs from the main processing hardware, sound engineers can dynamically customize and adapt entirely different environments.
Without running miles of new cable every single time.
Exactly.
Here's where it gets really interesting, though, because ultimate flexibility means absolutely nothing if the system crashes during a live broadcast or a major court hearing.
Yeah, and that brings us to the unit's mission-critical redundancy features. The device has built-in microphone detection to track usage and send out immediate failure notifications.
Okay, but the source mentions that if a critical fault occurs, it automatically routes audio to a backup within seconds. Wait, hold on. I have to push back on this. Yeah, wait, it switches to a backup in seconds.
Yeah.
I mean, in live audio, a few seconds of dead air can feel like an absolute lifetime.
It really can, yeah.
It's like an understudy leaping onto the stage mid-scene. Why does a high-end digital system take full seconds to switch over?
Well, if we connect this to the bigger picture, it is actually a calculated physical protective measure. It uses integrated relay mutes to prevent power-up transients.
Wait, transients? You mean like those awful speaker-blowing pops and cracks you get when someone unplugs a live mic?
Precisely. A relay is a physical mechanical switch inside the box. When the network drops and it fails over to the backup, those relays physically disconnect the audio lines for just a brief moment.
Ah, so it is waiting for the power and digital signals to stabilize.
You got it. It reroutes 24 channels of high-resolution audio to a completely different network and then safely unmutes the lines without blowing out a stadium's worth of expensive speakers.
Okay, wow.
Yeah, doing all of that automatically without a human lifting a finger is a massive engineering feat. That specific failover time and redundancy is actually the gold standard for high-stakes paging systems and large hospitality installations.
That makes total sense now. Those few seconds of silence are a necessary sacrifice to save millions of dollars in blown speakers. So what does this all mean?
I think it means we should appreciate the invisible bridges between the physical and digital worlds a bit more.
Completely agree. It reminds you that whenever you experience perfectly balanced, uninterrupted sound at a massive venue, it is all thanks to specialized, unseen hardware like this, quietly doing the heavy lifting in the background.
Catching all the disasters before they happen.
Exactly. So the next time you enjoy a perfectly seamless technological experience, ask yourself, how much of our modern world is actually just brilliant hidden tech quietly catching and fixing failures before you ever notice them?